Let me welcome you to the 12th lecture of Drilling and Blasting Technology course. In this lecture, we will discuss about the drilling pattern, but like every class, let us retrospect the previous lecture. In last few classes, we have read about the different types of drilling machines, their classification according to the drilling pattern and manner. Their drilling mechanism, principle, applicability and efficiency at various conditions were also discussed. We have also covered the accessories which are essential to a drilling machine like drill bit, shank adapter, coupling. In fact, modern drill machines are almost automated, computer fitted, where it is very easy to control every time machine is interactive with the rock condition, and the operators are very expert in operating these machines. If you look into this last three part, the drill bit, shank adapter and coupling, basically a drill machine may change its diameter of drilling by only changing these three part. If they are changing drill bit, drill rod, shank adapter and coupling, then the same drill machine can drill a different diameter drilling, and drill length can be extended only by changing this part only. So, basically one drill machine can be universally adapted for carrying out drilling in different conditions. But let us we have already covered these things in the previous classes. In today's class, we will discuss about the drilling pattern, and mainly we will discuss about the drilling patterns of the underground drifts and tunnels. So, our today's learning objective is the perspective of drilling in underground drifts and or tunnels, and various cut patterns essentially required for the subsurface excavations in underground drifted tunnels. We will observe the two videos where we can distinctly able to define that what is the basic differences in the drilling carried out in the surface and underground condition. So, let us go into the next slide and look into the surface drilling video first. So, what we do, we carry out surface drilling where we need to carry out blasting, and the explosive has to be inserted in the hole, and in surface we carry out this drilling either vertically or maybe a slightly inclined manner. So, what is happened, as the surface, we are standing on the surface of the rock, on the top part of the rock, it is very easy for us to carry out the drilling vertically, because we need not to hold the heavy drill rod or drill assembly. So, that is why it is very easy, we are carrying out the drilling in vertically, and the excavations are generally carried out in benches. That means, the vertically a number of slabs are created which are called benches. Benches are basically the rock slabs, and the drilling is carried out on the bench itself. So, basically surface drilling is carried out on the bench. You can see the mark is given and the drill rod is kept almost vertically. Then the rig is placed on the desired place, and the drilling is carried out either by rotary action or by hammering action. You can see it is a percussive rotary drill, where the percussive action is given along with some rotary action. So, mainly the excavation is drilling is carried out with the percussion, and rotation is given for the rotary action of the drill bit. And you can see the flushing media is taking out, allowing the rod to come out, allowing the chips of rock chips to come out from the hole. So, basically this is the method carried out in the surface, where the drilling is carried out either vertically or near vertically. So, it is very easy to carry out drilling in the surface condition, and the main difference between the surface and underground is that in surface we are having two open faces of the rock shelf. One is in the top part and another is the front part. You can see the front part, this is the face. So, this front part is free face and this top part is the another free face. So, there are two free faces available for blasting this place while we are carrying out drilling. So, basically the surface drilling is little bit different, and if you are comparing that to the underground, before observing one such drilling in the underground, let us understand few things. Say this is the rock shelf, this is the one rock shelf, this is another rock shelf. So, we carry out drilling in this rock shelf. So, it is vertically drilling carried out in this rock shelf, or near vertical drilling is carried out in the rock shelf. So, always in surface condition the drilling is carried out vertically, but in underground this is the surface, this is the underground excavation is being carried out. So, unlike surface excavation where there are two free faces for this rock shelf, one is at this side, one is at this side. In the underground condition, the only one free face is available in this side. So, the condition is little bit different from the surface to the underground, and that is why the drilling system is entirely different. So, let us observe this drilling system from this video. You can see this is the only free face available where the drilling is being carried out with the 4 boom jumbo drill. So, these are the different rigs, multiple rigs are available in this drill machine, and the drilling is carried out from these multiple rigs. Then after completion of the drilling, the explosives are inserted into the hole. You can see the explosive cartridges are inserted and then pushed by the wooden rod. The ladder is used for charging the explosive inside the hole in the top part. Then the blasting is carried out and the rock is excavated. So, new free face is created. You can see the new free face is created in this place, where that has to be drilled again after removal of this fragmented material. So, these animated videos are available in the YouTube. You can observe a number of other videos. This is the dislodging of the loose rocks are carried out. So, our purpose is to carrying out drilling in a single phase in case of underground, where only single free face is available. So, we have to carry out the drilling in that single phase only, and the problem is that as blasting in surface mines, there are two free faces are available. We can throw the rock in front direction, but here only one free face is available. So, the purpose is that we have to create another free face, so that the rock can be thrown on that direction. So, let us understand what is the difference between the surface excavation and the underground excavation. So, these underground tunnels drifts are very specialized excavation procedures, where the horizontal excavations are carried out below the ground. For tunneling, it is for the civil purpose, for drifts, headings, etc., for the mining purpose. These headings are may vary in shape, in cross sectional area depending on their uses, and the largest equipment has to be plying on that, depending on that size is also dependent, and the excavation method depends on the size, type of rock, method of working, etc. and for that we have to carry out the drilling operations in the mine or in the drift or the tunnels. So, these are the drill holes that has to be drilled inside the rock mass, where this is the only available free face. This is the only available free face. So, this one free surface is creating the confinement of the charge which are placed inside the drill hole. The confinement is very high. Instead, if we are having some excavation like this, where we are having some excavated ground like this, then the holes drilled at this position may utilize this free surface. So, the purpose of underground drift or tunneling is that first to create a free surface centrally, so that for the rest of the holes this free vacated area can act as another free surface, once in the front direction, another is in the this direction, can act as a free surface, so that the mimicry of the surface excavation can be carried out. Only in case of surface excavation it is vertical in nature, here it will be changed to the horizontal in nature. So, basically the purpose of underground drilling is that initially it has to be carried out such a way, so that the another free face must be created. Often what is happened, if the dimensions are very high, very large dimension, say this dimension may be 100 square meter, okay, 80 to 100 square meter. So, these are of very large dimension. In that case, a top portion, this top portion is only excavated by using the similar fashion which is carried out in the underground drifts or tunnels, and the rest part is carried out in a surface excavation technique. So, this is the surface drilling and blasting technique is practiced in case this is underground drilling and blasting is practiced. Blasting is practiced. So, these are the different types of modification may be carried out in the underground excavation while it is practiced in the actual field. Now, let us understand some terminology related to drilling. So, consider this is the complete face that has to be blasted in one go. So, in that case we may carry out drilling like this. Then these drillings are of different patterns, we will discuss that in our next few hours. So, this drilling is carried out, then we blast it. So, the blast holes drilled in the face of a tunnel or drifts are collectively known as the round when it is blasted at a time. So, a blast round or heading round is considered when a number of holes drilled in a same face and blasted together in one round, one go, it is called a heading round. So, here the entire face is blasted in one round. So, they are drilled first, then charged and blasted. So, they must be drilled and positioned efficiently, so that what is our objective? Our objective is to achieve the excavation, and say we have drilled up to this and we have we are able to got an refreshed excavation up to this portion. This portion is remain unbroken rock. So, this is called advance per round, or in that particular round, in that particular blast round we have achieved an advance of this. Often this may go into 90 to 95% for a good blast. It may achieve much lesser 0.5 to 0.6 times of the drilled length for a poor blast. It may over excavated if the geological disturbances are there, then you may achieve more than 100% advance also for a blast round if the geological disturbances are there. So, this advance in coal mines, this is called pool. So, basically this advance is the whole utilization factor where the drilled in a blast round the advancement of the phase is made. So, this objective of this blasting is to achieve the advance, and that advance is achieved by a blast round if the total heading is blasted in a single round. Next, let us understand the different terminology related to a underground drilling pattern, say for single phase drift and tunnels. So, as we have discussed, our objective is to first create another free phase. As we are having a single free phase here, we are having a single free phase here. We should create another free phase so that can act as another free phase for the rest of the holes. So, the free phase drilling is carried out first for creating the free phase, and that portion is called cut. So, basically cut is basically the area where drilling is carried out so that another free phase has to be created. So, first that another free phase has to be created of desired length. The free phase has to be created, free phase or free surface has to be created of desired advance length. Say if the desired if the free phase the user may not able to create the free phase of desired advance length, in the total blast round that advance cannot be achieved. So, in the cut area itself the desired free phase length has to be desired advance length has to be achieved. So, the drilling has to be carried out in the cut area for creating the another free phase. So, first is the cut area where the drilling has to be carried out, that is cut drilling pattern has to be followed, cut drilling pattern has to be followed in this cut area. Then the cut spreader, that means if this is the tunnel, first an initial cut is created, then that cut area has to be spreaded to achieve sufficient area, so that other drill holes which are drilled in the adjacent of that area can easily utilize this free phase area, as the possible another free phase for their blasting. So, this desired cut area has to be created. So, that desired cut area has to be created by the cut spreader holes. So, basically the cut area consists first initial cut, then the cut spreader. So, cut area consisting two part, one is initial cut, another is the cut spreader that has to be created first for creating the another free face, and in the rest portion the blasting is as same as the bench blasting which is carried out in the surface, but in case of surface it is vertical, in case of underground it is horizontal. So, all the holes placed in this position are horizontally drilled. These are the front views, are horizontally drilled, so that these holes can utilize this free face, this face as their burden, and this portion can be utilized as their free face. So, the objective of this underground blasting is first to create one initial cut, then spread that cut to have a desired free surface area, then the normal blasting as in the surface is carried out, that is carried out for the rest part. So, that is the main production blasting carried out. So, the drilling must be carried out for the same, and finally, the drilling has to be carried out in the periphery area. Their objective is that there should not be any over excavation or over damage to the surrounding rock mass, so that the support cost should not be increased. So, the production has to be carried out up to this similar fashion to the surface blasting, then cautious blasting has to be carried out, controlled blasting or controlled excavation has to be carried out in the periphery part, so that the damages will not occur in the remaining underground rock mass, then that will increase the support cost. So, basically if you see the total area in the underground drift is divided in a number of part. First, the initial cut part where the first free surface is created, then the free surface is extended up to the desired length, desired area, so that that can accommodate the blasting carried out in the remaining rock mass by providing two free faces. Then the normal area of excavation, which is called stopping excavation, stopping holes or easers holes. This is also called easer holes, stopping holes or easer holes. So, where drilling easer holes are drilled to achieve the main production blasting, main production excavation. Then the contour holes, which are basically divided in three parts. One is the roof contour holes. So, this is the roof contour holes, this is the wall contour holes, and lifters are basically the floor contour holes. So, these are basically the together you can say contour holes or periphery holes, which are to be drilled in a special manner and excavated, blasted in a special manner, so that the damages to the remaining rock mass should not be there. So, basically this is the purpose of drilling carried out in the different portion of an underground drift or underground tunnel. So, this objective of this designing of heading round basically depending on the desired utilization of the heading, cross sectional area, rock and drilling parameters and skill of the miners, because these patterns are often very different. You can have a very critical pattern also, but the stopping holes, roof holes, wall contour holes, floor contour holes are always drilled horizontally and they basically give the mimicry of the surface blasting, surface drilling. The expertization is basically required in the cut holes and cut spreader holes, so that the desired length of free face has to be created, length of additional free face has to be created there, which basically govern the advance can be achieved by a blast round. So, basically all those technical requirements or planning designing requirements are there in the designing of a cut. So, basically the designing of the cut is the heart of the underground drilling, and this designing of cut principally divided in a number of types. The main are the wedge cut, pyramid cut, drag cut, fan cut. This is we can clubbed in a special type of excavation technique. They are more or less similar. Burn cut and coromand cut are more or less similar, and ring drilling is also another type of cut which is practiced. So, basically these are the different underground cut which is created for providing a free surface to the underground drifts or drivages. Basically ring drilling is not for the drift and drivages. This is basically practiced where already a free surface is existing. In that case, this ring drilling is practiced. Each type of cut has many variations of design to make them adaptable to a particular formation. The cut must be broken and completely removed to create a void for expansion and relief prior to the blasting of the stopping holes. So, the cut must be blasted with a prior delay than the stopping holes. The remaining holes in the round are timed to fire in a sequence, breaking to nearby created free face and allow most of the section to move forward into the open tunnel or drift sections. So, that means first the cut has to be created, this has to be carried out in the first, then the cut spreader has to be carried out, that is in the second delay, then the stopping holes that has to be third, then the contour holes may be fourth, fifth, sixth, or maybe in the simultaneously in the fourth. So, that if you are observing their time of arrival, this has to be carried out first, then we have to give some delay for this, then again with some delay to this, again with some delay to this, again with some delay to this, then lastly this one. So, basically this is the sequence of excavation in the drilling pattern, in the drilling carried out in the underground drifts or tunnels. So, let us first discuss about the wedge cut or V cut, where the centrally one wedge is formed to create the free surface. So, that means if this is the tunnel cross section area or drift cross section area, we have to create this drilling. If we are observing the plan view like this, in a manner like this, so that their ends are trying to meeting each other, you can see the extensions are this direction. So, that is why these holes are drilled in this way in some inclined manner. You must recall this designing of these angles we will discuss later on. So, these are drilled such a manner, so that an wedge will be formed. So, what will happen, the moment we will insert explosive and blast it, an excavation free area has to be created like this. So, this portion will be excavated in a form like this. So, that is why an wedge excavation may be achieved using this pattern. So, basically wedge cut is also called V cut is carried out to achieve an initial excavation first, then we extend the excavation by the cut spreaders. These are the spreader holes, and finally, we are able to achieve a free excavation here. So, you can see these are the different modification of the blasting. This hole is called stab hole, these are the short length drill hole is carried out so that gradually the advancement can be achieved, but this may exist, may not exist, this portion may exist, may not exist. We can start with this one also depending on the type of rock. So, these are required in the hard rock formation, otherwise in soft rock formation we can start directly from this place. So, that is why we can have a drilling like this, and you can see a free phase of advance of 2.3 meter can be achieved in this condition. So, wedge cut is very useful and very commonly used in a mining and tunneling sector. The blast holes are drilled at an angle to the face with the so that an uniform wedge can be formed. The cut displaces a wedge of rock out of the face in the initial blast, and this wedge is widened to the full width of the drift is in subsequent blast, each blast being fired with a detonator of suitable delay time. The apex angle is nearly kept 60 degree, actually the limit is 1 radian. This type of cut is particularly suited to large size drift with laminated fissures rocks. The problem you can understand, as we are giving an initial angle centrally, that means the drilling length is basically governed by the width available in the opening. So, that is why that is the drawback of this wedge cut system, otherwise this wedge cut is very useful for the excavation. Pyramid cut or diamond cut is basically a double wedge cut. In our previous cut you have seen the wedges are there in the horizontally. Similarly, if you see from the side view, the wedges are there in pyramid cut in vertically also, whereas in the wedge cut these holes are like this. So, there is no inclination, you have observed in that case there is no inclination for the holes horizontality of the holes in the wedge cut, but pyramid cut is basically a double wedge cut where the wedge is formed. If you are observing the top view in this way also, and if you observing in the side view in this way also. So, that is why basically a pyramid shape is created centrally and then gradually that is extended. So, pyramid cut is a double wedge cut which is most of the time followed in case of a very hard rock formation where wedge cut has to be followed. Otherwise, pyramid cut is little bit difficult to practice for the drilling if the manual drilling is being practiced. So, basically if you see this type in this type 4 or 6 short holes are derived at the middle of the face, which the end to form a cone or pyramid shape. The pyramid or diamond cut is a variation of the wedge cut, or you can say it is a double wedge cut. The length of the holes are basically 15 centimeter more than the other types of holes. The charging is done mainly at the apex, so that it can create a free face, but the difficulty here is that the control of the drilling is very difficult unless and until there is a expert drilling crew is available which can adjust these angles, that is the wedge angle of the vertical holes and the horizontal holes. The pyramid drilling is very difficult. So, let us stop at this position we will continue with the other cut in the next class, while we will discuss the drilling pattern class 2. Thank you.